Class, in this video, we go over rule number 6 in your note packet for anti-differentiation. We're going to do rule 6, the indefinite integral of the function f of x equals 1 over x, on the middle of page 73 in your note packet. So in a rectangle, right, it says we're going to find the indefinite integral of the function f of x equals 1 over x. And so the rule is, you can write in a rectangle, the antiderivative of 1 over x with respect to x. Well, 1 over x is the same as x to the minus 1. And so the antiderivative of x to the minus 1 with respect to x, right, these are equivalent, is equal to the natural log of the absolute value of x plus c. To see why that's true, recall from the rules of differentiation. If a function g of x is equal to the natural log of x, then g prime of x, the derivative of g of x, is equal to 1 over x. So the antiderivative of 1 over x with respect to x has to equal the natural log of x plus an arbitrary constant c. But we put absolute value bars around x because you can't take the log of a negative number. So the antiderivative of 1 over x with respect to x is equal to the natural log of the absolute value of x plus c. And so the first example, middle of page 73, under rule 6, we got to find the antiderivative of 2 over x with respect to x. Well, 2 is a multiplicative constant. It can be brought out in front of the integral sign. So this is equal to 2 times the antiderivative of 1 over x with respect to x. Well, the antiderivative of 1 over x is the natural log of the absolute value of x. So this is equal to 2 times the natural log of the absolute value of x. And then we add our arbitrary constant c. In example 2, we've got to find the antiderivative of 3x minus 5 over x squared plus 4 over x. So we can find this antiderivative by finding the antiderivative each term by term. And so before we do that, right, we got to rewrite this. Minus 5 over x squared is the same as minus 5 times x to the minus 2 power. And 4 over x, right, can be written as 4 times 1 over x. So the antiderivative of this function is equal to the antiderivative of 3x minus 5 times x to the minus 2 plus 4 times 1 over x. Well, the antiderivative of 3x, right, using power rule, add 1 to the exponent, get 2 divided by 2, is 3 halves x squared. The antiderivative of x to the minus 2, when you add 1, you get negative 1. And then divide by negative 1. Negative over negative is positive, so minus 5 over minus 1 is plus 5. And we have times x to the minus 1 power. And then the antiderivative of 4 times 1 over x is equal to 4 times the natural log of x from our rule up here. And then we add the arbitrary constant c. So the antiderivative of this function here in example 2 is equal to this in parentheses. All right, class, so we're continuing with example 3 at the top of page 74, dealing with rule number 6, the indefinite integral of the function 1 over x. So in example 3, top of page 74, we have the antiderivative of 1 over x squared minus 3 over x plus e squared. E squared here is actually a constant, right? There's no x in here, right? So using your calculator, you can see that e squared is approximately equal to 7.3891. And so before we anti-differentiate, right, we got to rewrite the function. 1 over x squared is the same as x to the minus 2 power. And minus 3 over x can be written as minus 3 times 1 over x. And then we have the constant e squared. And now we anti-differentiate term by term. Antiderivative of x to the minus 2 using the power rule. When we add 1 to the exponent, we get negative 1. And then we divide by negative 1. So x to the minus 1 divided by negative 1 is the same as the negative of x to the minus 1 power. And then the antiderivative of minus 3 times 1 over x is minus 3 times the natural log of the absolute value of x, right? From rule number 6. Minus 3 is just a multiplicative constant. We're just carrying it along. Antiderivative of 1 over x is the natural log of the absolute value of x. And then e squared is a constant. So the antiderivative of e squared with respect to x is just e squared x. Okay? Derivative of e squared x is e squared. And then we add our arbitrary constant c. So the antiderivative of this function is equal to this in the rectangle.